Welcome to the Hitchhiker's Guide to Calculus. My name's Kevin, and I'll be your guide to Chapter 1.9, Limits at Infinity. Before we get started, there's an important fact here that we all have to agree on that's going to make everything else easier going forward. We have to agree on what this limit, as x approaches infinity, of 1 over x has to be. Now, our numerator is just 1, just a constant value of 1. Our denominator is x, which is growing larger and larger because x is getting closer to infinity. So if I take a small value and I divide it by an infinitely large value, or a number that keeps getting bigger and bigger, hopefully we can agree that that has to tend towards 0. So this limit will always evaluate to 0. And now, keep in mind, it doesn't really matter if that numerator is not 1. If the numerator is 5, who cares? 5 divided by something getting bigger and bigger goes to 0. If the denominator is x squared, who cares? That just makes the denominator grow faster. It's still 1 divided by an infinitely large value. I'm going to get 0. Now let's apply that fact to a couple practice problems. All right. We can see in this top limit, as x approaches infinity, we're dealing with 3x squared minus 2x plus 1 over 4x squared plus 3. The important part here is finding what the degree of the numerator and denominator is. Actually, the highest degree in the whole problem. Since we can tell that the highest power is x squared, we're going to divide every single term in this expression by x squared individually. Okay, we're going to clean this up, simplify each term, which should work out pretty nicely. And if we divided everything by x squared, we'll find our new expression. The first term, the x squareds will cancel out. We'll just get a 3. Our next term, one of the x's will cancel. We'll have minus 2 over x. Our next term will just be 1 over x squared, all divided by. First term in the denominator, the x squareds will cancel out, leaving us with just a 4, and then plus 3x squared. Don't forget that we're still taking the limit as x approaches infinity, but now here's where we get to implement that fact from before. All of these terms in here, 2 over x, 1 over x squared, 3 over x squared, if we agreed before that those better go to 0, they're still going to 0 now. So if all of those go to 0 and kind of essentially cancel themselves out of the problem, we're left with just 3/4, and that's our limit. All right, this will work for any problem that looks like this, a rational function with a polynomial numerator and polynomial denominator. All right, we can see down here the largest power is 3. So we'll divide every term in this whole expression by x cubed. Clean this up. And then we'll cancel out some pieces and parts. We'll have the limit as x approaches infinity of, and this time it'll be just 4 over x minus 1 over x cubed, all divided by 5 plus 2 over x squared. Right. Now everything left over that's got an x in the denominator, at least an x in the denominator, is going to all cancel out, leaving us with a whole bunch of zeros. So what's this end up being? 0 over 5. So the limit as x approaches infinity here should equal 0. Now, if you want to learn the shortcut to evaluating these limits, click the link that should be popping up right in front of you in the middle of the screen right now. Don't forget to hit subscribe and like the page to get alerts about all the content we release each week.